Like during like COVID or whatever, I was just sitting there and I would like do it like 50 million times. It was really bad. I what? Oh, the bottle? Oh yeah. Huh? Oh my God. All right, so let's get started. So the senior talent show, which first of all, I think that there should always be a senior talent show. That's just my personal opinion. Is scheduled to take place this afternoon. Michael Senator Ray is in the SAT class practicing his act. Bottle flipping. Could you imagine somebody coming onto the stage and being like, "Yes, I'm going to bottle flip." I feel like Argos would be great at this. It would be awesome. It would totally be awesome. All right. He tells his friends that the probability of successfully landing a water bottle right side up is 20%. Assume that each water bottle flip is independent. Okay. So, first question. If he flips the bottle 10 times, how many do you expect to land right side up? Why? I mean, y'all said that like la duh. So say it again. 20 times 10 is 2. I'm sorry, 0.20 times 10 is 2. All right. So the way we did that is we said N times P. That's 2 flips. Okay. Is this a binomial? Is it? What's our acronym? BINS. Is it got a success and a failure? Okay. Is it independent? Is it? It's number 5. There it is. Okay, cool. Thank you. Is it the same probability every time? Okay, cool. You got 10 times. You got 10 times that you're flipping it. Right? Right here. Good so far? Okay. What is the probability that he makes exactly 2 flips? Okay. So what we're going to do is we're going to go into our calculator and we're going to go binom PDF. Remember, you're going to put the number of trials, you're going to put the probability, and then you're going to put what value you're looking for, which is 2. So you go to menu, probability, distributions, and then it's binomial PDF. You're doing great, David. Winning at life. Okay, for those of you who like to see like the formula, or if you're ever asked for the formula, you have 10 choose 2 of 20%. We're gonna have 2 successes and 8 failures. And if you plug that into your calculator, you're gonna get 0.302. Please make sure that you can do both of these, that binomial PDF as well as the NCR. So yeah, so if you have like unknown, then you can do NCR. Yeah, you can do the NCR equation. He's like, I got this one. I'm doing that. Remember that we saw yesterday that we could have written this like this, the 10 choose 2, and then all this junk. Okay, just a refresher. Good so far? Good. All right, what is the probability that he makes less than 2 flips? Okay, less than 2 flips. So on this one, we're going to use binomial PDF. Okay, and we're going to say 0, 0.20. Thanks, babe. And I'm sorry, 10, JK, 10.20 and 1. Why are we putting 1 as our value? Okay, because we want to make less than 2. We want to make less than 2. So that means 1 flip, right? Now, we're going to say again. That, so when you do this, right. Okay, so we're going to put in 10 choose 0, 0.20 raised to the 0 power times 0.8 raised to the 10th power. plus 10 choose 1 of 0.20 raised to the first power times 0.80 raised to the ninth power. Okay, so just like what y'all were talking about, we've got the probability of the 0, and then we got the probability of 1. So 0 flips or 1 flip, because that's less than 2. Again, make sure that you can type it into your calculator. Take a moment, type that in. Tell me what you get. Dun, dun, dun. So when you do this, you get 0.3758. Okay, on the next question, it says, what's the probability that he makes 2 or more flips? So 2 or more is going to be 1 minus everything we just did. So 1 minus 0.3758. And that's going to give us 0.6242. Okay. The thing I want you to pay attention to on here is he makes exactly 2 flips, makes less than 2 flips, makes 2 flips or more. And look at how we changed up how we did our equation. Does that make sense? So exactly, we're using PDF. Less than, we're using CDF. Greater than, we're doing 1 minus binomial CDF. CDF is less than, and so yes, it's taking into consideration your 0 flips and your 1 flip. Yeah. Like, right. 0, 1, 2. Yeah. We okay? Cool. All right, on the next one, it says, after the first 10 flips, Michael wants to do more, but his teacher's getting annoyed with all the noise and tells him he must stop flipping once the bottle lands right side up. So he gets one more chance to kind of get his life together. So we might have a bottle flipping competition. That's fine. You will all lose, all of you. Okay, so find the probability that he lands it on the first try. So what's the probability that he lands it on the first try? 0.2. Right? Because we got independent, right? Find the probability that he fails on the first try and lands on the second try. So what's the probability that he fails on the first one? And then on the second one? Okay, so 0.8 times 0.2, he gets 0.16. And then if he fails the first 2 and lands on the third one, what is that going to be? So he fails the first one, fails the second, and then got the last one. Yeah. Okay. Liar.
I was just testing.
That's okay. Don't you ever? No, I'm just kidding. Sorry. All right. On number 8, find the probability that he fails the first 3, lands on the fourth. 0.8 times 0.8 times 0.8 times 0.2. Right? 0.1024. Okay, so really quick, I want us to put that data into a cute little table. Okay, so on the first try, he would have had 0.2. The second try, it was 0.16. Third try, it was 0.128. Next one, 0.1024. Can you do the last 2? Somebody say no. Actively. It's on this call.
So then I just, and also so to be quiz on the same day.
That's so sad. All right. We should have gotten 0.0819 and 0.0655. Okay. So just to define this, we were doing this until the bottle lands right side up, right? Okay, so this is defined as until the first success. Okay. Throw back to Algebra 1, which y'all probably took in either 7th or 8th grade. Okay. when you have something like this, what is this going up by? I'm sorry, what is this going down by each time? So we see it's geometric. How do we know it's geometric? Go ahead, finish it. Okay, so geometric is going up by a multiple, right? Did you say it's pre-cal? Nah, bro. Nah. No. You learned this back in like algebra. Like I taught this last year, homie. Yeah. Yeah. All right. So the way you could have found this is you could have taken the second number and divided it by the first number, and it should work for all of your numbers. If it doesn't, then it's not geometric or you mess something up. Probably the second. Okay, so this is what we call geometric. And the reason why, just like you said, we're multiplying by something consistently over and over again. Now, we can write a generic rule for finding the probability that he first lands the bottle on the K flip. You say int?
Yeah, we all like, when we're about to have success, we've always put an alternative.
Right. Well, today is going to be to the K because we're looking at the successes, and K is represented by successes. K is very successful. Very demure. All right. So we're going to write a rule. Okay? If we found the probability that he lands it on the 10th try, then that would be 8.8 raised to the 9th power. We would have 9 failures and 1 success. Okay. The way we could write out this generic rule is we could say, hey, if we're trying to find this success, so the probability of K happening is 1 minus the probability of the success raised to the K minus 1 times our probability that it's successful. Okay. So the way I see this is failure raised to the however many successes minus 1, okay, or however many trials minus 1 times your probability of being successful. Yes, no, maybe. Yeah. Tiny X. Move. Feel better? Okay.
Oh my gosh.
You're doing too much, homie. Look, here's a dot. There it is. Okay. So, so failure times success. And then up here, however many successes, I mean, normally it's going to be until he lands the first one. So this is going to be however many, like, trials minus 1, right? Because we want to have that 1 success at the end. Yeah. Okay. How many flips do you expect it to take for the bottle to land right side up? All right, so 20% probability, right? Okay, so that would be 1 out of 5, roughly. Okay, another way we could have gotten that is 1 divided by P. So 1 divided by 0.2 is 5. Yeah, I know. Fancy math. What would this data look like on a histogram? Skewed, right? Okay, why? Okay, so we have cute little, I'm giving you just like a little figure. Okay, here's our first trial, landing it on the first try. Then it gets a little wonky afterwards. Okay. And we see that on the trend of the probability of X in our table. We see that it's decreasing each time, right? Okay. Good. Nothing too crazy.
Sorry, so what's the answer?
1 out of 5.
Wow.
Because if I have a 20% probability, change that to a fraction.
Well, why would you change it to a value?
We're wanting to know how many flips it would take for us to land the bottle right side up. If we have a probability of 0.2. Yeah? Oh God. Okay. You could also do it with this formula right here, right?
So what?
You could also do it with this formula right here on the left-hand side.
So what in the world were we just doing on like 8? We're filling out this whole table and just talking about nothing.
It was showing that it was geometric.
And so then why did the answer go on this if we were told that we can still do all? So if you took 5 times and expected to do one, why would it be 1 out of 5 times when we just did like, if you did 5 trials, it would be smaller? Yeah.
Are you guaranteed for it to actually land right side up when you do 5 trials?
No.
Like we could be an epic failure, or we could get all 5, right? But we're just looking at what is the percent that probability of it actually landing right side up. All right, let's review. Flip to the back page. Okay, so we talked about geometric distribution. All right, still holding true to all of these cute little acronyms. On this one though, we're actually gonna use bits instead of bins. Okay, so it's still binary, either success or failure, still independent. The T represents trials until success. So that's how you know the difference between binomial and geometric. Trials until success. Okay. And then S, same probability. All right. We talked about the formula. And we said P of X equals K is equal to 1 minus P raised to the K minus 1 times with a dot times P. Okay. Sorry. This is your failure probability. This is your success probability. And this is the number of failures. We also talked about the shape. It's going to be skewed right. We talked about the center, where we found the mean being 1 over P. That is on your formula sheet. Less. Excuse me? Yes, for geometric. And then we talked about, well, we really didn't talk about this one, but you're going to see it in just a second. The variability. The way you find the standard deviation is you take the square root of 1 minus P divided by P. That is also given on your formula sheet. What's good? Would you be asked to find the variance for a problem like this? You could be squared. Wouldn't be really much of a reason to, but you could. Standard deviation versus standard deviation squared. All right. I do want to mention on this, there is a geometric PDF and CDF as well. Yay. So look into your calculator. Don't you love the calculator? Yay. Still under probability, still under distributions. And you just have to scroll a little bit more and it says geometric PDF and CDF. The only thing that's different on this one is you're going to have geometric PDF and you're going to put the probability and then whatever value. Okay. Should be for both. Okay. So I want you to try A, B, C, D. Go ahead and knock out A, B, C, D, and then we'll do E and F together. Okay. Take about 5 minutes and then we're going to talk. When test day rolls around, because his classmates are tired of having to supply pencils for Mason, only 15% of the students will give Mason a pencil when asked. Today is test day, and Mason begins asking randomly selected students for a pencil. Let Y equal the number of students Mason asks until he finds someone who's going to give him a pencil. Does the random variable Y follow a geometric distribution? Be sure to check the appropriate conditions. So, what are our conditions for this one? Is it binary? Okay, we got to define the success and failure. So what's the success? Gets a pencil. What's the failure? Okay. All right. What about independent? Yeah. How do we know? Okay. All right. What about T? Okay. So trials until he gets a pencil. He's going to keep asking people. Okay. And then is there the same probability of success each time? Yep. What's the probability? 0.15. All right. So yes, it is. All right. What is the probability that the third person will ask is the first person who gives him a pencil? So we're going to find the probability of Y equals 3, which means that we have a 0.85 chance of failure. That's going to happen 2 times, 0.15 raised to the first power. When we plug that into our calculator, we're going to get 0.1084. You could have done this with a geometric PDF, typed it into your calculator, boom, there it is. What's the probability that Mason gets a pencil by the third person he would ask? Okay, so how would we go about doing this one?
Probability of success is income of 5, up or down 3, lower down 1, up or down 3.
So we're going to say the probability of getting less than 3. So that's going to be 0.15 plus 0.85 times 0.15. Oh, let's make this actually like legible. Okay, 0.15 plus 0.85 times 0.15 plus 0.85 squared times 0.15. Okay, so what is this actually representing? Well, if he gets success on the first one, if he gets success after the first failure, second person, and then if he asks 2 people, but then gets it on the third one. Okay. And just like what you were saying, you could have done geometric CDF. Geometric CDF. Okay, and that would have been 0.15, comma 3. And that would have been 0.3859. All right, how many people should Mason expect to ask before getting a pencil? Well, if we use mu equals 1 over p, then that means mu is going to equal 1 over 0.15, which is equal to about 6.67 people. Should Mason be surprised if he doesn't receive a pencil until he asks at least 10 people? Calculate a probability to justify your answer. So what are we going to do here? What's our inequality look like?
It would be, the coverage of Y, yeah, 10 and 14.
Okay. Which means that we're trying to find the probability of less than 9 or equal to 9. And we're going to subtract that from 1. And so that's going to give me 0.2316. You could have done this with 1 minus geometric CDF. So is this result likely? Is 0.23 likely? Is 0.23 likely?
It's not likely, but it's not impossible.
So, right, but like, will he really have to ask at least 10 people? Probably not. So it's not likely. I'm sorry, not unlikely. Like he could go and ask 10 people and probably would get a pencil before he asked 10 people, but he could have to ask 10 people. Yeah. Like think about the kid in class who never brings a pencil. How many people do they have to ask? Normally like everybody around them, and then they give up and they go ask the teacher, right? Say what? That's so rude. So rude. And that's why I don't have any more pencils. So he shouldn't really be surprised. He's probably gonna have to ask a ton of people. All right, find the standard deviation. Remember our standard deviation formula, and this is given to you on your formula sheet. We're gonna take the square root of 1 minus p divided by p. And so that's gonna give us the square root of 1 minus 0.15 divided by 0.5. And that's gonna give me 6.15 peeps. Questions? Need practice?
Yes, please.
Okay. Give me 1 second. All right. So determine if each of the variables described below is geometric. Studies suggest that approximately 10% of the people are left-handed. Cal talks to every person in front of him in line at a hardware store and asks them if they're left-handed or right-handed. Let X be the number of people he must talk to until he finds someone who is left-handed. So, is this geometric? Why? So, success or failure. Okay. Independent. Trials until success. Okay, so really want to focus on the until he does whatever. Okay. And then same probability. Okay. In a large study of 2,000 adults, 69% stated that they prefer desserts that are drinkable rather than ones that must be eaten with a spoon or a fork. Desserts that can be drinkable. It's like root beer floats, milkshakes. Okay, cool. All right. Suppose this sample represents the general population of adults. When Cal talks to the people in line at the hardware store, he also asks them if they prefer desserts that are drinkable over the ones that are edible. Let Y be the number of people who prefer drinkable dessert when asking 8 people in line. Is this by geometric? Why? There's a fixed number of trials, so then you would use bins instead. Okay? So the number of trials, this would make this what kind of thing then? Binomial. We're gonna understand the difference. Fixed number of trials or until number of successes. Good? Okay. On number 2, it says Polly uses a random number generator to select an integer value between 1 and 100. Let X represent the number of values she must select until she gets a value that is a perfect square. Explain why X is a geometric. Why is this a geometric? Until she gets a value that is a perfect square, right? Okay. Identify the probability of success. So what is that going to be? Say again. It's the dead silent for me. We know what a perfect square is, right? Okay, so yeah, y'all were like real quiet, yo. All right. How many perfect squares do we have between 1 and 100? Okay, so let's list them out because we don't know. Okay, cool. So we got 1, 4.
5, 36, 49, 64, 81.
How many numbers are there?
It seems like it's.
Oh my gosh. Tori is not having it with y'all. All right.
Oh, well, I feel dumb because I literally could have like, that's your guys. And this.
You're doing great. All right, so that's gonna be point 1. Describe the distribution of X using the information about its shape, center, and variability. So we know it's geometric. So is it skewed right? Okay, so we got skewed right. What's the mean gonna be? So 1 divided by the probability. So that's gonna be 10. So the mean is 10. Okay, and then what about the standard deviation? Remember how to calculate that one? Okay, so square root of 1 minus p divided by p. Type that into your calculator. Yeah. Dun, 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 dun. Damn. Okay, so like 9.49-ish. Okay. Questions on that one? Okay, I'm gonna skip down. There we go. Yeah, number 3. All right. So summarize this one on your paper. And then I want you to answer each one of these because this is practicing with the geometric PDF, CDF, all that jazz. Okay, so go ahead and take a moment. Dude, you need to go to a GI doctor, man. All right. According to a survey from the Pew Research Center, 33% of the workers respond to work-related emails or messages outside of working hours often. Assume this claim is true for Reagan's list of Facebook friends. Suppose that Reagan starts asking randomly selected people from her list of Facebook friends how often they respond to work-related emails or messages outside of work hours. Never, rarely, sometimes, or often. Assume the responses are independent. Reagan is interested in knowing how many people she'll have to ask to find the first one that says often. So, is this geometric or is it binomial? Is this geometric or is this binomial? Why? Okay, so it says until the number of successes, right? Or until somebody says often. Okay, so define the random variable of interest and state how the random variable is distributed. So this is going to be W is defined as the number of people Reagan asks until someone says often. So if it says define your variable, you have to say whatever letter is equal to whatever the situation is. Now, we've already said that geometric describes the situation. Okay, and you have a probability of 33% or 0.33. All right, what is the probability that Reagan must ask 5 people until she finds someone who responds often? Okay, so we're going to say the probability of W equals 5 is equal to the probability of failure. And that means that 4 people have to fail to have 1 person succeed. And when you do that, you're going to get 0.066. Questions on that one so far? All right, what is the probability that Reagan must ask less than 3 people? Okay, so what are we going to do on this one? Less than 3 people. So we went, go ahead. Okay, so CDF. Okay, so you can type that in. Or you could sit there and you could find the probability of 1 plus the probability of 2, which would be 0.33 if she did it on the first one. It would be 0.67 times 0.33. And that would give me 0.5511. Anytime that it says show work, this is what it's wanting you to show. Okay? It's wanting you to show, hey, I'm adding these things together. If we want more than 3 people, then we're going to say 1 minus the probability of less than 3 people, right? So we're going to do 1 minus 0.5511, which would give us 0.4489. How many people should Reagan expect to ask before she finds someone who responds often? Well, if we take 1 divided by our probability, we're going to have 3.03 people, about 3 people. And then if you calculated the standard deviation, you should get 2.48 people. To the test. Okay, so on the test, you need to be able to do binomial distribution versus geometric. Okay, make sure that you know how to find the mean and the standard deviation for both. Okay, those are 2 separate different formulas. You are given them on your test, but you need to be able to identify the difference between the 2. Remember, geometric is until success, and binomial is fixed trials. Okay. You need to be able to find the expected value. Okay. If you don't remember how to find that, go back to like our first or second lesson from this unit. Be able to interpret the standard deviation in context. Interpret standard deviation in context. Okay. Be able to use the binomial formula. So NCR times the probability of failure raised to the k minus 1 times the probability of success. Okay. Really goes back to whether or not it's binomial or geometric. It's going to make you identify whether or not a situation has violated the binomial random variable conditions or not. So make sure that you know that. And then be able to find the probability of when it's exactly a number, less than a number, and more than a number. Okay, so that's your binomial CDF versus PDF, your geometric PDF versus CDF. Okay, that's it. Okay. As I have this. Let me pause this.